For the next two classes, we're going to be looking at rational functions, which is section 3.6. Okay, so a rational function is a function of the form p of x over q of x, where p and q are both polynomials. So we assume that p and q have no factors in common. If they happen to have a factor in common, then it's going to cause us to have to graph the graph a little bit different. And we'll talk about that later in the video. But the main thing is it's a polynomial over a polynomial. So where a polynomial is a smooth, continuous curve, a rational function is going to look something like this, where we're going to have what's called vertical and horizontal asymptotes, and we'll talk more about those in a few minutes as well. But it's going to look like it's got two or even three parts times to these. So just kind of understand what you're going to be looking for with this. Okay, I want to start with just the very basic rational function. This is the reciprocal function that we mentioned earlier in chapter 2. So if we were to graph this, obviously we could plot a few points, and that would be helpful in graphing it. But what you should notice here is when we look at the domain on this, we have to realize that x is not going to be able to be 0. Because if we have x being 0, then we have a division by 0 error. So what we're going to do is we're going to have a vertical asymptote here at 0. And vertical asymptotes are graphed as dotted lines. Hopefully you can see this dotted line here that I'm putting in. So we have this vertical asymptote to represent this domain restriction that we have. So as we get closer and closer to this vertical asymptote, the behavior of the graph is that it's going to get larger and larger and larger. So as we come in, as our x is coming in towards 0, so as we're going from a 0.1 to a 0.01 to a 0.00001, you can see that the function value is actually growing tremendously as well. So as we go in, it's actually going to get closer and closer to this vertical asymptote, and it's going to keep getting closer and never actually touch that vertical asymptote. Same thing if we're approaching it from the negative direction here. If we're coming in to 0 or to this vertical asymptote from the negative direction, we're going to be looking at these same type negative values getting closer and closer to 0. And as we do that, the function itself is going off to negative infinity. So it's getting smaller in the negative direction there. Okay, so we said that x equals 0 would be our vertical asymptote, and we also have a horizontal asymptote across here, and it would be graphed with a dotted line as well. It is possible for your function to cross a horizontal asymptote. Your function should never cross a vertical asymptote, though. So our domain on this one would be x is not 0. Our range, if we're looking at the range here, what happens is we actually have a little gap in our graph across here where our horizontal asymptote is. So our range is going to be y is not 0. Because remember, you go from the bottom to the top, and the only place that we exclude that is this horizontal asymptote across here. Okay, there's different characteristics of rational functions, and I'm going to go through and take these one by one for these three functions so that you can kind of see how to approach each one of them. So anytime you're asked to find the x-intercepts for a rational function, the only thing you really need to look at is the numerator. So we're going to set our numerator equal to 0 and solve, and that's going to give us our x-intercept. So looking at this one, I would have x minus 3 equals 0. So my x-intercept is going to be 3. So it would be the point 3, 0. So that's where it's crossing the x-axis. This one is in its factored form, so we're just going to take each of the factors, set those equal to 0. So I'm going to get 3 and also negative 4. So my points would be 3, 0, and negative 4, 0. So I would have two x-intercepts for this one. This one is not factored, so I would need to factor it. So that would be x minus 1 times x minus 1. So because they're the same, I'll just set that equal. So I'm going to get 1, 0 as the x-intercept. So whether it's factored or not, you need to go ahead and factor it, get it to its factored form, and then set each of the numerator factors equal to 0, and that will give you your x-intercept. So the other key, or another key characteristic of a rational function, is its y-intercept. We actually find the y-intercept just like we found other y-intercepts, and that's by letting x be 0. So we're going to plug in 0 into the function, and that's going to give us our y-intercept. So our y-intercept here would be -3/4, so it would be 0 and -3/4. This one, if I plug 0 in, hopefully you'll start seeing that you can do these a little quicker. If I plug 0 in here, I'm going to have -3. If I plug 0 in there, I'll have 4. Plug 0 in here, I'll have -2. Plug 0 in there, and I'll have 1. So this is going to be -12 over -2, which is 6. So my y-intercept would be 0 and 6. Over here, if I plug in 0, then if I put 0 in the numerator, I'm just going to get 1. If I put 0 in the denominator, I'm going to get 3. So my y-intercept there is going to be 0, 1/3. The next characteristic that we want to find for rational functions is our asymptotes. And we have both a vertical and a horizontal asymptote. So they're always graphed as dotted lines, as we mentioned. And another key thing is when you give a vertical asymptote, it always needs to be written as x equals and whatever that number is. If you're given a horizontal asymptote, it's y equals, because these are actually equations of lines. This is the equation of a vertical line, and this is the equation of a horizontal line. So it's not a point and it's not a single number. It's an equation of a line, and it needs to be written as such. So our rational function has vertical denominators at the place that the function is undefined, and that's going to be where the denominator is equal to 0. So I want to start us out with vertical asymptotes, and then we'll move to the horizontal asymptotes. Okay, so we said that we have vertical asymptotes where the function's undefined, and so that's the same thing as looking for our domain restriction. So what we're going to do to find our vertical asymptote is we're going to set that denominator equal to 0. So we set the numerator equal to 0 to get our x-intercepts, set the denominator equal to 0 to get our vertical asymptote. So this one would have a vertical asymptote at -4, and this is exactly the way you need to write it. Okay, it needs to have the x equals and the number there. This one is actually going to have two vertical asymptotes. I'm going to set each of these equal to 0. If it was not factored, then you would need to factor it if it could be factored. So we get x equals 2/3 and x equals -1. So we have two vertical asymptotes, and you need to list both of those. Over here, we can't do anything really with the denominator, can't factor it any further. So 2x plus 3 equals 0. Okay, so this would be our vertical asymptote. Okay, so moving on to taking a look at our horizontal asymptotes. I've listed a few rules here over the next couple slides, so hopefully one of them will be understandable for you. On this one, you've got a rational function, and so here we have our polynomials. When you're finding the horizontal asymptotes, what you're going to need to look at is the degree of the numerator and the degree of the denominator. So in finding our horizontal asymptote, if the degree of the numerator is less than the degree of the denominator, then our horizontal asymptote is always going to be y equals 0. If the two of these degrees equal each other, then it's the ratio of their leading coefficients. And if the degree of the numerator is larger than the denominator, we have no horizontal asymptote. So here's a couple examples. This one has a degree of 1 for the numerator and a degree of 2 for the denominator. So what that means is, since the degree of the numerator is less than the degree of the denominator, then we're going to have a horizontal asymptote at y equals 0. Here, the degree of the numerator is 2 and the degree of the denominator is 2. So when they equal each other, we're going to look at the ratio of our leading coefficients. So it's going to be 3/4. So we'll write it as y equals 3/4. This one has a degree of 3 and the denominator a degree of 2. So when the degree of the numerator is larger, then we're going to have no horizontal asymptote. Okay, so this is just another way of kind of writing these. If we look at these examples here, this first one, we have the degree of the numerator and the degree of the denominator are both the same. So if they equal each other, it's the ratio of the leading coefficients. So my leading coefficient here was 1, and also here was 1. So that's going to be y equals 1 over 1, or just y equals 1. Okay, unfortunately, horizontal asymptotes are easier to find in their non-factored form. So what we're going to do here is just multiply this out. So that's going to be here, and then we'll have 3x squared plus x minus 2. So we can see that our degrees are the same. So if we have degrees that are we're going to look at the ratio of the leading coefficients. So we'll have y equals 1/3. Over here, the degree of the numerator is 2 and the degree of the denominator is 1. So if the numerator degree is larger than the denominator, we're going to have no horizontal asymptote. Okay, another thing that you may be asked to do for rational functions is identify its domain. Finding the domain is the same as finding the vertical asymptotes, except you write it as does not equal. That's the only difference. So it's still going to focus on these denominators. So if we were finding the vertical asymptote, we would say x equals -4. That would be my answer for a vertical asymptote. But for the domain, what we're going to have to do is we're going to have to say x is not -4. Or if it asks you to write it in interval notation, it would be -infinity to -4, and then -4 to infinity. Here, we'll do the same thing. 3x minus 2 equal to 0, and x plus 1 equal to 0. So we get 2/3 and -1. So those will be our asymptotes. So our domain is going to be x is not 2/3 and x is not -1. Or as interval notation, be -infinity to -1, -1 to 2/3, and 2/3 to infinity. And then for number 3, we'll set that denominator equal to 0. So that's going to be the value that has to be excluded for the domain. Okay, for the range, we actually need to look at the graph and come up with the range for these. Okay, so over here on the calculator, I'm going to put in the x minus 3 divided by x plus 4. Make sure that when you enter these rational functions, you put parentheses to group them together. Otherwise, you are not going to get the right graph. Okay, so when we look at this graph, we've already said that it has a vertical asymptote at -4. And so you can kind of see how if I were to draw a vertical line straight through here, then that would be where the vertical asymptote is. And it also has a horizontal asymptote at 1 we had identified. So it looks like it's going across here at 1. So when I go to identify the range on it, what I see is if I'm looking from the bottom to the top, the only y value that gets excluded is here at this horizontal asymptote. So y equals 1 is the only place that's excluded. So when we write the range for that, we are going to have to indicate that for the range. So our range on this one is going to be from -infinity to 1, and then from 1 to infinity. Okay, I'd like for you to put both of these in your calculator, and let's take a look and see if we can identify the range for these. Okay, so looking at this one, I've entered in the calculator here, the one that we were just looking at. Be sure that you include parentheses that group the numerator. Okay, so this graph is what you should see. You'll see your vertical asymptote at positive 2/3 is going to be coming down through here. And we had identified another vertical asymptote at -1. So you can see that. And we said that we have a horizontal asymptote on this one at 1/3. So it's coming across here at 1/3. So what for our domain we would have already said was x is not -1 and x is not 2/3. But for the range is a little bit trickier here. You've got the horizontal asymptote at 1/3, which means it's not going to cross the one and get higher than 1/3. And then this is not going to go down below this value here that we see. So it's a little bit tricky to come up with the range on this one, but we want to identify this. Our range is going to go from -infinity up to this positive 1/3. And then we need to figure out what this smallest value is here. So I'm going to find the minimum using the calculator. So we'll look at finding the minimum between -1 and 1. We'll just put 0 in as a guess. So our minimum value looks like it goes down to this 5.82. So our range is going to be from -infinity to the 1/3, and then from 5.82 to infinity. Okay, so this is what you basically should have had from -infinity to 1/3, and then the 5.82 to infinity. This one actually doesn't quite get to the 5.82, so it would have been fine if you put a parenthesis there as well. Since we're approximating that value, I'm not going to give you one quite this hard to find the range on, but that's the idea behind how to find it. So let's look at this last one here. Put that in your calculator. Okay, so enter your equation in here, and then once you have it entered, be sure you have your numerator group with parentheses and the denominator. And then let's look at the graph of this. Okay, so here we have a graph. You can see that your vertical asymptote, we had identified it to be at -3/2. So here it goes here. We had no horizontal asymptote. We actually have what's called an oblique or slant asymptote. We're not going to work with trying to find those. So our range is going to be from -infinity up to this highest point here, and then from this point to positive infinity. And you can find the values there by doing the second, calculate your maximum. And so the maximum we're actually going to want to be the one down here. So let's put in -4 and -1. Maybe our guess is -2. And so it looks like -4, -5 is the smallest value. So the first part of our range would be from -infinity up to -5. And then if we want to find this value here, we're going to do second, calculate the minimum. And that minimum looks like it's going to be somewhere between 0 and 2, possibly around 1. So our minimum is 1, 0. So our range then is going to be from -infinity to -5, and then from 0 to positive infinity. Okay, so this is the range that you should have gotten. So your calculator can be very helpful as far as finding these values for you to use. Okay, so when you go to sketch your rational functions and put it all together, you want to factor if it's not already factored, find your x and y intercepts, find your vertical asymptotes, find your horizontal asymptotes, and then basically try to use those characteristics to sketch it all together. Okay, here's one, and we're going to kind of look at this one and go through the different parts. So to find your x-intercept, if you recall, we set the numerator equal to 0. So that means we're going to set each individual part equal to 0. So we're going to get x is 1 and x is -2. So our x-intercepts are 1, 0, and -2, 0. Okay, for our y-intercept, we plug in 0 to the equation. So when I plug 0 in here, I'm going to have -1 plug 0 in here, I'll have 2. This will be 1. And this is going to be negative 3. So I'm going to have negative 2 over negative 3, which will be 2 over 3. So I'm going to have 0 and 2/3. So 0 2/3 is going to be somewhere in here. I've got 1 0 as a point, and I've got negative 2 0 as a point. Okay, my domain is going to be coming from the denominator. So if I set this denominator equal to 0, so I'm going to get negative 1 and 3. So basically what I have found here is I found my vertical asymptotes, and my domain is going to be x cannot be negative 1 and x cannot be 3. So the reason we have a vertical asymptote at those locations is to keep us from actually having a graph at those locations because they're excluded in our domain. So our domain is x is not negative 1, x is not 3. And our vertical asymptotes are x equals negative 1 and x equals 3. Okay, our horizontal asymptote, if we were to multiply this out, I'm going to have x squared, that's a squared, plus x minus 2, and then I'm going to have x squared minus 2x minus 3. So you can see that these have the same degree and the same leading coefficient. So my horizontal asymptote then is going to be y equals 1. It's the ratio of the leading coefficient. So I'm going to put a dotted line across here at 1. And I'm also going to put a dotted line to represent my vertical asymptotes at negative 1 and at positive 3. Okay, the last thing we want to do is fill in some points here just to kind of get an idea of where our values are going to be. So this is where you can use the table on your calculator. So let's say maybe we do negative 3. We already know what negative 2 is. Negative 1 is undefined. So we have all those. Let's try 2, 4, 5, and we maybe could do negative 4 as well. So I'm going to get these values from the calculator and fill those in. Okay, so I use the table function on my calculator that we've talked about before to get a few values to plot here. So if I plot negative 3 and approximate that decimal, I have a point here. And then 2 was negative 1 1/3, so somewhere in here. 4 is 3.6, so up here. 5 is 2 1/3, and then I also had negative 4, which was here. So we can kind of use our calculator and use the points that we have, and let's go in and sketch a graph of this. I'm going to change my color here just to kind of show. Okay, so this is going to be, we're going to get close to this asymptote. We're going to go through these points, and then we're going to come down and get close to this asymptote here as well. Get closer and closer. Up here, we're going to have a function that looks something like this. It comes down. It goes through the points that we've plotted, and then it gets closer and closer to the asymptote. And again, your calculator can give you a much better graph, but I do want you to understand where it's coming from instead of just the calculator giving you the graph. So you will be asked to identify these different characteristics here. Okay, so looking at this, we had not finished the range part. The range, if we look at this, if we only had the first part and the last part, then we would need to exclude this value here at 1. But because we have the middle part actually crosses that. So our range in this case is going to be negative infinity to positive infinity. Okay, I would suggest you trying this one on your own. So pause it and give it a try and see if you can come up with the graph and the different characteristics. Okay, looking at this one, we need to find our x-intercepts. So that means we're going to set the numerator equal to 0. So we're going to need to factor this. So we'll set each part equal to 0. We'll get 3 and -2. So our x-intercepts are 3, 0, and -2, 0. So I'm going to come and plot those points, 3, 0, and -2, 0. Okay, the y-intercepts, we're going to plug 0 in for x. So when I do that, I'm going to have -6 on the numerator and 0 on the denominator. This is an undefined expression. So what that means is we have no y-intercept. Okay, for our domain, we're going to work with the denominator. So we're going to set the denominator equal to 0. We'll factor that. So we're going to set each factor equal to 0. And we get 0 and -3. So those are our vertical asymptotes. And our domain is going to be x is not 0 and x is not -3. Okay, so I'm going to go in and graph these vertical asymptotes. So I've got one at 0 and I've got one at -3. Okay, our horizontal asymptote, if we look at the degrees, these are equal to each other. So we end up with, so our degrees were equal and our leading coefficients were equal. So we do the ratio of the leading coefficients, we get y equals 1. So we're going to have a horizontal asymptote coming across here. Okay, so now we're ready to complete our table. Okay, so we have gotten a few values off of our table. So if I plot these, -5 and 2.4, it's going to be here. -4 and 3.5, -2 and 0, -1 and 2, 1 and -1.5, 2 and -0.4, 3 and 0. So now we're just going to use what we know about asymptotes to kind of connect these. This one gets closer to the horizontal asymptote, so it's actually going to come up. I can't really show it here, but it's going to get closer and closer to the asymptote. This one is going to start out close to the asymptote. It's going to cross through these points, and then it's going to get closer and closer to this other vertical asymptote. And then here it's going to be close to the vertical asymptote. It's going to pass through our points, and then it's going to get close to the horizontal asymptote. And you can always check these on your calculator to make sure that they look right. So when we look at the range on this one, there are no excluded values going from the bottom to the top. So our range is again going to be -infinity to +infinity. Okay, here's another one for you to try. All right, on this one, if we're going to find our x-intercepts, to find the x-intercept, we set the numerator equal to 0. So we see that our x-intercept is -2. So we only have one x-intercept on this one, -2, 0. Our y-intercept, we're going to find f of 0, which means we're going to plug 0 into all this. So I'm going to get, when I plug 0 in, I'm going to have 2 over -3. So my y-intercept is 0 and -2/3. For the domain, I'm going to set the denominator equal to 0. I'll factor that. So I get x equals, set each factor equal to 0, and I get x equals -3 and x equals 1. Those are my vertical asymptotes. And the domain is going to be x is not negative 3 and x is not 1. So I'm going to go and graph these. So here's my vertical asymptote at negative 3, and then also one at x equals 1. Okay, my horizontal asymptote, I'm going to look at the degree of the numerator and the degree of the denominator. So the degree of the numerator is 1, the degree of the denominator is 2. So because the numerator degree is less than the denominator degree, my horizontal asymptote is going to be y equals 0. So I'm going to come across here at 0 and put that in. Okay, so from here we're going to fill in the the table. Okay, so from our table we get these values, or you can just plug the values into the function, either way you want to do it. So negative 5 and negative 1/4, negative 4 and negative 0.4, negative 1 and negative 0.25, 0 and negative 2/3, 2 and 0.8, 3 and 0.4, and 4 and 0.28. Okay, so this is actually enough for us to kind of see that it's going to get close to this horizontal asymptote and then come down toward the vertical asymptote. This one's going to do something like this. And if you're not sure about connecting these, I've just worked with them enough to kind of know what their behavior is going to be. If you're not sure, just look on your calculator to fill the rest of it in, and you should have a graph that looks like this. So the range on this one, again, is going to be negative infinity to positive infinity. If it did not have this middle section, so several of our graphs have had this middle section. If it didn't have the middle section, then we would have needed to have excluded here where the horizontal asymptote is at 0. Okay, on these, we're not going to graph any more of them because I think we've practiced that enough, but I would like for us to practice stating the domain on them. So this one, the domain you're going to have is x is not going to be 3, just because if you set that equal to 0, then you'll see that x is not 3. And here our domain is going to be x is not negative 2. Okay, if we look at the graph for these, this is the first one here, and our vertical asymptote you can see at negative 3. And if we look at this, we can identify what the range would be from the graph itself. So the range on this one's going to go from negative infinity up to 0, and then from 0 to infinity. Because you remember you're looking from negative infinity to positive infinity. So the place here where we have this horizontal asymptote, the function never equals 0, and because of that, 0 is not part of the range for this particular function. We look at the second one here, we'd already identified our vertical asymptote to be negative 2. Our horizontal asymptote would be 3 because that would be the ratio of our leading coefficients. So when I look at this, the range is going to start down here at negative infinity, and it takes a break here at the horizontal asymptote, and then it picks up again just on the other side of it and goes to positive infinity. So my range is going to be from negative infinity to 3, and then from 3 to infinity. Okay. Or another way to write that would be simply y is not 3. On WebAssign likes the notation in interval notation. In general, usually this is acceptable notation, so it just depends on the platform that you're using for this. Okay, one thing I wanted to show you on your calculator as far as how it's behaving near the asymptotes. If we look at this one, our vertical asymptotes we would get by factoring the denominator and setting those equal to 0. So if I factor this denominator, I'm going to have going to have 2x minus 1 and x plus 2, which that means that if I set each of these equal to 0, I'm going to get 1/2 and negative 2. So those are going to be the places when I look at my table that I'm going to have an error message. So here's 0.5, and here is -2. So I'm going to expect to have an error message at the places where my vertical asymptote would occur. The other thing I want you to notice is as we get closer to those vertical asymptotes, what happens is our function value gets either really large or really small, depending on which direction it's coming from. So here on this one where we're looking at the 0.5, as we come in from the upper side of 0.5, which would be these values here, you can see that it's going toward negative infinity, which is what our graph is doing. If we go in toward 0.5 from the left side and go up this way, then you can see it's going toward positive infinity. And if you look at the table, it's getting larger and larger here too. So that's what you're going to see on this table. If you look at around this -2 as an asymptote, you can see that it is getting closer and closer to either positive infinity or negative infinity the closer it gets to that vertical asymptote. Okay, for the horizontal asymptotes, the horizontal asymptotes are more the behavior as x gets really large in either in the positive direction going toward positive infinity or as x is going toward negative infinity. We want to look at the behavior. So here, this would kind of be showing it going toward negative infinity. And if you notice, these values are getting closer and closer to 1.5. And that was what the horizontal asymptote would be here is the ratio of the 3/2. So our horizontal asymptote would be 3/2, and that's what these values are getting closer and closer to because that's the same as 1.5. Here, if you're going toward positive infinity, you can see that these values again are getting closer and closer to 1.5. So here's one last one for you to identify the domain and the range for. If you look at this one, the domain is going to come from the denominator. So we'll set this denominator equal to 0. So we're going to get -2 and 1 as the places that the denominator would be 0. So my domain is going to be the set of all x such that x is not -2 and x is not +1. The range is going to be dependent on the horizontal asymptote. So my horizontal asymptote for this one is going to be, the degrees are the same, so it's going to be the ratio here. So it's going to be 2/1 or 2. So when we look at the graph, here we have a horizontal asymptote at 2, and you can see our vertical asymptotes that we just identified there at -2 and at 1. So when I look at the domain is going to be, like we said, all the numbers except 1 and -1. For the range, it's actually going to be all real numbers because this is one that has this middle part and it does touch that horizontal asymptote here in the middle. Okay, that's the last example that we're going to look at today. Our next video is going to focus on the second part of section 3.6 and kind of putting it all together.